Imagine if every machine in a factory, aircraft, or power plant could whisper a warning before breaking down. That is the promise of predictive maintenance AI, and it's one of the most high-impact AI applications used across industries today. In this project, you'll build a system that analyzes sensor data, maintenance logs, and operational behavior to detect patterns that humans simply can't see. Instead of fixing equipment after it fails, this AI predicts failures in advance, cutting downtime by 30 to 50% and reducing maintenance costs by up to 40%. Think of it as transforming machines from silent workers into intelligent partners that protect productivity and safety. This matters because even a single hour of equipment downtime can cost companies hundreds of thousands of dollars. By learning how to implement this system, you step directly into the world of industrial AI, a field where skills are rare, demand is high, and the impact is measurable. For students and early professionals, this project is not just a technical milestone, it's a confidence-building gateway to high-value rules where AI meets real-world engineering. To understand the importance of predictive maintenance AI, picture three major industries relying on uninterrupted performance. In manufacturing, factories depend on robotic arms, conveyor belts, and precision machinery, where unexpected breakdowns can halt entire production lines. In aviation, safety depends on predicting component failures in engines, landing gear, and avionics long before they occur. In the energy sector, wind turbines, solar inverters, and grid systems must operate continuously to maintain stable power supply. Across all these industries, unplanned downtime costs over $50 billion every year, and a single hour of failure can cause losses ranging from $100,000 to $1 million. Predictive maintenance cuts that risk significantly, prevents catastrophic equipment failures, and extends machine lifespan by 20 to 30%. That's why companies in industrial IoT, aerospace, renewable energy, and smart manufacturing are aggressively hiring talent capable of building these systems. For AI students, this is the perfect blend of data science and engineering, a field where your work directly influences safety, efficiency, and profitability. To build predictive maintenance AI with confidence, you'll develop a powerful skill set that blends machine learning, time series analysis, and sensor intelligence. You'll learn how to classify failure conditions, estimate remaining useful life, and detect anomalies hidden deep inside vibration, temperature, and pressure signals. You'll analyze degradation curves, seasonal effects, and sudden shifts in sensor behavior using techniques from both time and frequency domains. You'll also design meaningful features like rolling statistics, FT-based transformations, and rate of change metrics to improve model accuracy. On the tools side, you'll work with Azure IoT or AWS IoT for ingesting sensor data, use InfluxDB for time series storage, process large workloads with Apache Spark, and communicate with edge devices through MWTD. Soft skills matter too, understanding industrial operations, communicating with maintenance teams, and presenting ROI-driven results that show how your model reduces real costs. Recruiters highly value candidates who combine technical depth with operational awareness, making this skill set extremely competitive. Let's walk through the complete workflow for building a predictive maintenance solution. You begin with data acquisition, using datasets like NASA's turbofan engine dataset or Microsoft's predictive maintenance sample. Here, you gather vibration, temperature, pressure, and RPM readings that represent how machines behave over time. Next, you move into feature engineering, where you create statistical features such as mean, standard deviation, and skewness, combine them with FFT frequency features, and extract temporal signals like time since last service. Then you develop your models, using random forest or XGBoost for failure classification, and LSTM networks for time-dependent patterns. You'll also build a regression model to estimate remaining useful life with high accuracy. After modeling, you tune decision thresholds to avoid excessive false alarms while still catching failures early. Finally, you deploy a real-time monitoring system with dashboards, alerts, and automated scheduling integrated with CMS tools. Beginners can finish this in 8 to 10 weeks, while intermediate learners may complete it in 4 to 5. This is more than a project. It's a full production-ready pipeline, Start building this today and put it on GitHub. Predictive Maintenance AI opens doors to some of the highest value roles in industrial data science and smart manufacturing. With this project in your portfolio, you can target positions like Predictive Maintenance Engineer, Industrial IoT Data Scientist, Reliability AI Specialist, and Manufacturing ML Engineer. Employers look for candidates who can demonstrate measurable cost savings, understand industrial equipment behavior, and build models that reduce downtime in real environments. They want professionals who can deploy real-time systems, communicate findings clearly, and justify technical decisions with ROI-focused insights. The resume impact is powerful when you include keywords such as anomaly detection, sensor analytics, industrial IoT, and time series ML. Companies hiring in this domain include Siemens, GE Digital, Bosch, ABB, Schneider Electric, Spark Cognition, Sensei, and Augury. Salaries are strong, 8 to 18 lakhs in India and $90 to $160,000 globally. This project shows recruiters that you're not just learning ML, you're ready to apply AI to real industry challenges with measurable business value.